Welcome everyone. Now this circuit was used as a feedback circuit in Wien Bridge oscillator. So let us found the V out divided by V in for this feedback circuit. This V out by V in will be our beta because this is our feedback circuit. Now this C1 and R1 is denoted as Z1 and this C2 R2 is denoted as Z2. So now Z1 is basically your R1 and we have the capacitor, so we can write this as R1 plus 1 divided by j omega C1. Fine. So this is your Z1. And what is Z2? Z2 is basically your R2 parallel to this C2. And this impedance of C2 is 1 divided by j omega C2. Fine. And we know how to find the parallel combination. We multiply both, so we have R2 multiply by 1 divided by j omega C2 divided by the addition of both, that is R2 plus 1 divided by j omega C2. Okay, let us solve it. We are going to have Z2 is equal to R2 divided by j omega C2, and now we are going to take the LCM. So this will be R2 into j omega C2 plus 1 divided by j omega C2. So this j omega C2 and this j omega C2 is going to be cancelled out, and we are going to have R2 divided by, let me write one first, 1 plus j omega R2 C2. So this is your Z2. So Z1 is R1 plus 1 divided by j omega C1, and Z2 is your R2 divided by 1 plus j omega R2 C2. Fine. So we have found the Z1 and we have found the Z2. Now what we need to find is V naught by V in. Now we can use the voltage divider rule to find V naught by V in. And by voltage divider rule, V naught by V in will be equal to V naught by V in will be equal to Z2 divided by Z1 plus Z2. Because if I want to find the V naught, this will be equal to V naught is equal to Z2 divided by Z1 plus Z2 multiplied by V in, which is the input voltage. So this means that V out by V naught is equal to this thing. Find Z2 divided by Z1 plus Z2. So I'm going to write it over here, and then I'm going to put these values of the Z1 and Z2, or put these equations of the Z1 and Z2. So V out by V in is your V out by V in is your Z2 divided by Z1 plus Z2. So now Z2 is this thing, Z1 is this thing. So I'm going to put in the values. This is V out by V in. Z2 is your R2 divided by 1 plus j omega R2 C2. Fine. And then we have the division, and then we have Z1, which is R1 plus 1 divided by j omega C1, and then plus Z2, which is again this thing, R2 divided by 1 plus j omega R2 C2. Okay, let us solve it. We are going to take the LCM. First, we are going to write this R2 1 plus j omega R2 C2 as it is. Fine. And now we are going to take this LCM for this. The LCM of this is going to be equal to 1 plus j omega R2 C2 into this one, j omega C1. Fine. So this is the LCM of this denominator term over here. Fine. We have j omega C1 and we have this term. So I have write it over here. Now what will be these terms? R1 has 1 in the denominator, so R1 will be multiplied by this whole LCM. So we are going to have R1 into 1 plus j omega R2 C2 into j omega C1. So we have done the R1 part. Then we have 1 divided by j omega C1. So we have to multiply this 1 plus j omega C1 with this thing, with this one. So we have 1 plus j omega R2 C2, this part, fine, because we have j omega C1 already present, so we need to multiply this with 1. So when we multiply this with 1, we get the same thing, which is this thing. So the second part is done. Now for the R2, R2 have 1 plus j omega R2 C2. R2 needs to be just multiplied by this term, fine, because LCM is this. So we are going to have R2 j omega C1, fine, and this is your expression. Okay, now this 1 plus j omega R2 C2 is going to be cancelled out with this, and this j omega C1 is going to move to the numerator. So we are going to have j omega C1 R2, fine. This j omega C1 R2 has come here. So we have j omega C1 R2 divided by these terms. We need to simplify these terms. Okay, R1 into 1 plus j omega C1 into j omega C1, fine. First of all, multiply 1 by this. We are going to have R1 j omega C1, fine. And then we have this thing, which is we are going to have minus omega square, because we have j square, iota square. So iota square is minus. Then we have the omega square, and then we have R1, R2, C1, C2, fine. And then we have this term, which is 1 plus j omega R2 C2. So let me write it over here. We have 1 plus j omega R2 C2, and then this term, which is, let me write it as j omega R2 C1, fine. Okay, so we have, let me draw a line over here so you do not get confused. We need to simplify this. Okay, so from here we are going to have, let me draw a line over here. Okay, now from here we are going to have j omega C1 R2 divided by j omega R1 C1. This is your j omega R1 C1, and then we have minus omega square R1 R2 C1 C2 plus 1 plus j omega R2 C2 plus j omega R2 C1. Okay, let me write it in a proper form. This is j omega C1 R2, fine. And then we have, I'm going to write this 1 minus omega square R1 R2 C1 C2 first, the real part first. And then we have the imaginary part, j omega, j omega, j omega. So j omega is common from these three, and we have R1 C1 plus R2 C2 plus R2 C1, fine. So we have this expression. Now when the phase shift is 0, it means that this term is going to be real. For this term to be real, this term is going to be equal to 0. Why this term is going to be equal to 0? Because when this term is equal to 0, j omega and j omega is going to cancel out, and we are going to have a real term. So this term must be equal to 0 for this whole term to be real. So that we have phase shift of 0 degree. So we are going to have 1 minus omega square R1 R2 C1 C2 is equal to 0, which means that omega square R1 R2 C1 C2 is equal to 1, which means that omega square is equal to 1 divided by R1 R2 C1 C2, which implies omega is equal to 1 divided by under root R1 R2 C1 C2, fine. And omega is 2 pi f, so we have 2 pi f is equal to 1 divided by under root R1 R2 C1 C2, which means that the resonant frequency for this circuit, that will be equal to f is equal to 1 divided by 2 pi under root R1, R2, C1, C2. Let me name it as equation 1. So this is the resonant frequency of the Wien Bridge oscillator. Fine. And that has been derived by using this term equal to 0. Okay, now when this term is equal to 0, j omega and j omega is going to be cancelled out, and we are going to have V naught by V in. From that equation, we are going to have V naught by V in. Okay, so this term is going to be 0. J omega and j omega is going to be cancelled out. So we have C1 R2 or R2 C1 divided by R1 C1 plus R2 C2 plus R2 C1. Fine. So we have R2 C1 divided by R1 C1 plus R2 C2 plus R2 C1 divided by R1 C1 plus R2 C2 plus R2 C1. Fine. So, and this is your beta, because this is a feedback circuit, so I can say that this is your beta. So this beta is equal to R2 divided by C1 divided by R1 C1 plus R2 C2 plus R2 C1. Now if I talk about A is your gain. So we know that beta A should be equal to 1 for sustained oscillation. So A should be equal to 1 divided by beta, which means that A will be equal to R1 C1 reciprocal of this plus R2 C2 plus R2 C1 divided by R2 C1, which means that the gain of the amplifier needs to be, that is A is equal to, okay, R1 C1 divided by R2 C1. Let me divide it by the RD terms. R2 C2 divided by R2 C1 plus R2 C1 divided by R2 C1. So gain is this C1 and C1 is going to be cancelled out. So we have R1 divided by R2 plus C2 divided by C1 plus 1. Now the gain of this circuit, because this is connected in non-inverting mode, the gain of this is 1 plus R3 divided by R4. So this 1 plus R3 divided by R4 needs to be equal to R1 divided by R2 plus C2 divided by C1 plus 1. 1 and 1 is going to be cancelled out, and we are going to have R3 divided by R4 is equal to R1 divided by R2 plus C2 divided by C1. This is your equation number 1. Now because beta, which is the attenuation factor, which is the feedback circuit, that is equal to 1 by 3. So A should be 3 theoretically, and practically it should be greater than 3. So for A is equal to 3, this, because A is 1 plus R3 divided by R4, so this should be equal to 3, which means that R3 divided by R4 should be equal to 2. And for that, for R3 divided by R4 is equal to 2, we are going to have R1 is equal to R2 and C1 is equal to C2. So when this condition is met, we are going to have R3 by R4 is equal to 2. So for sustained oscillation, R3 divided by R4 should be equal to 2. The ratio of R3 divided by R4 should be equal to 2. Practically, it is kept higher than 2 to have sustained oscillation. Thank you.